And a couple of years back, the City of Oakland Police Department tried an interesting experiment. They introduced a pilot study with technology called automated license plate readers. What that is they put a camera on a bunch of their police cars. The camera is always scanning, and anytime the police car passes by some parked car, the camera will scan the license plate and automatically read the license plate and make a note in a police database of the license plate of the car that was seen and where it was seen and when it was seen. Okay, so I mentioned this is a pilot the Oakland Police Department was trying out. You can imagine how this might be useful for police. If a car is stolen, they could find where it is. If a car was involved in a crime, they could go back retrospectively and find out all the locations where it had previously been seen. Potentially very useful. Also, potentially some privacy implications for people. And I got the data. I got the data set. So what I wanted to do was I wanted to take a little time to show you, walk through some of this data, and look at what can be inferred from this kind of data. All right. So I got the data set from the police experiment from the City of Oakland's public records site, and I downloaded it and put it into a spreadsheet and then loaded it into our programming environment. So the first thing I did was I took a look to see what's in this data set. And you can start to see what's in the data set. It's a very simple table with just 3 columns. And interestingly, something like 2.7 million rows. And each row represents one time that a license plate was scanned by the system. It shows you in the first column the license plate number, the time when it was scanned, and then the GPS location where the parked car was seen, where that license plate was seen. Okay? So lots of data here. All right, so the first thing I started to do was to try to make some use of this data, start poking through it. It's a little clumsy. Why did they call these column names red VRM and red timestamp? I don't know. I thought that was a little weird. So the first thing I did was I renamed the columns to a column name that made a little more sense to me. And I started staring at this data. And what's the first thing you'd do with a data set like this? I don't know. I know what the first thing I did was I wanted to know, was my license plate in there? Had my car been seen? So I started scanning through this data set. But it turns out, nope. I guess I don't spend enough time in Oakland, at least during the time of this experiment, so my car wasn't in there. But in any case, it's a lot of data. All right, so let's start to get a feeling for what you can learn about someone using this data set. If we knew the license plate of their car, what could we learn about them? Well, you can imagine we could start to learn where their car has been seen, and now you can think about what privacy implications that might have. So since I couldn't find myself, I started thinking, who else could I look for in this data set? And I had a good idea. I thought, let's look for the mayor of the City of Oakland. She's a public figure. It seems fair game to try to find out where her car has been seen. And so the first thing I had to do was I had to find the license plate number of her car. And how was I going to do that? Well, it turns out I did a little bit of sleuthing on Google, and it wasn't that hard. I found a news article that was talking about how she hadn't paid her parking tickets. And if you take a look at this news article, at the top, there's this picture of her car. And oh, look, there's her license plate number. All right. So I now knew the license plate number of the then mayor of the City of Oakland, Jean Quan. So I thought, let's go look and see where her car has been seen. So that's what we're going to do. We're going to search in this table with a where statement to find all of the rows that correspond to an observation of her license plate. And we can see there's about 6 of them there at different points over this, different points in time and different locations throughout the City of Oakland. Now, I don't know about you, but when I stare at GPS coordinates, that doesn't mean anything to me. So I realized I would really like to have a visualization of this data to try to understand where that was seen. So we're going to plot this on a map. That seems like a reasonable visualization. And so we're going to write some code to plot these points on a map, and then we can take a look and see what we see. Now, it turns out that to do that, this data isn't quite in the format we're going to need to be able to plot it on a map using the handy map plotting features of the data science library. So the first thing we're going to have to do is we're going to have to deal with this data a little bit to get it into the format we need it to be. And that's not unusual. Whenever you have a large data set, it's common that one of the issues you often have to deal with is first getting the data, modifying, manipulating the data so it's in a format that you need it to be, so it's be useful. Another activity you often have to do is some kind of data cleaning. Often there's errors or funny stuff in the data that maybe isn't quite right, maybe that it wasn't entered in right. And that's certainly present in this data set. Though I'm not showing it to you here, there's also instances in this data set where it looks like the license plate probably wasn't read quite right by their scanning system. There was an error in the license plate number. So if we were going to use this seriously, we'd have to figure out what to do about those errors, and we'd have to figure out how to clean the data set. But this is just a demonstration, so I'm not going to worry about that aspect for now. So we're going to get this data into a more useful format. And what we're going to need to extract is the latitude for each time the license plate was seen and the longitude separately. And those are together in one column. I'm going to need to split them out into two separate columns. So I'm going to write some Python code to do that. And before this video, I took the time to figure out how to write that Python code and wrote it so that I wouldn't waste your time figuring it out on the fly. So let me just show you how you can do that. The first thing we're going to do is we're going to take this data. This data is a string, and we're going to find the comma, and the latitude is going to be before the comma, and the longitude is going to be after, except we're going to want to get rid of these parentheses. So we can use the split method to separate by the comma and take out everything before and everything after. And I was able to write some functions to extract the latitude from this kind of a string and the longitude from this kind of string. And basically what I do is I split it to get the latitude, to get the stuff before the comma, and then I eliminate the parenthesis, and that gives me just the latitude part. And then I convert that to a float, from a string to a float. And for the longitude, I do the same thing, except I want what's after the comma. Okay. So to give you an example, here's some examples showing you how this pulls out the latitude part, and the get longitude function pulls out the longitude part. Now I have those as numbers, and I can add each one separately as a separate column. So then I modified this table by using the get latitude function to pull out the latitude from each location and add it as a separate column. And do the same thing for the longitude. And now I've got two more columns on there that have separately the latitude and the longitude. I needed them separate because the code I'm about to use for visualization for plotting on a map requires them to be separate. Okay. All right. So now I'm going to take this augmented data set, take the rows where Jing Quan's car was seen. This is her official car as a mayor. Then I'm going to pull out just the latitude and the longitude, and I'm going to show that on a map, plot that on a map using the built-in method for plotting on a map. Okay, and the resulting picture looks something like this. Ta-da! There's our map, and you can see here's the location where Jing Quan's official car was observed in this data set. Now, I don't know if you know anything about the city of Oakland. We can zoom in a little bit here, and we'll see a little bit more about where her car was seen. If you're a local, you might know something about these locations, but I wouldn't expect you to necessarily know if you're not a local. If you're a local, you might know that up here is City Hall or city headquarters. That seems reasonable that her official car would be seen near her offices. Maybe a little more interesting is down here. What's down here? Well, if you're a local, you know that down here is the courthouses, but it's also the headquarters of the city police department. Okay. So with that information, Now I'm going to ask you, why was Jing Quan's car seen so many times down here? It looks like 4 separate times down here by police headquarters and the courthouses, but only once up by City Hall and her offices. So take a moment, pause the video, and see if you can form any guesses for why that might be. All right, when I teach a class here at Berkeley, the first thing everyone says is, oh, maybe she was down at the courthouse paying her parking tickets. Love it. But no, that's not the reason. If we think about it a little bit, police headquarters, that's where police cars and police officers start their shift and end their shift, because their cars parked there when they're not during their shift. So that kind of means it's guaranteed that these police cars are going to be spending a certain amount of time near police headquarters. They start their day there and they end their day there, so for sure they're going to spend some time there. So it sort of stands to reason that police cars will spend more of their time near police headquarters and probably less of their time overall in the outlying areas. So what that does, that introduces a bias in our data set. When her car is parked near police headquarters, it's very likely to be scanned, because it's pretty much a certainty that every one of those cars is going to be going by here. When her car is parked up by our offices, maybe it's less likely to be scanned, because sometimes a police car happens to go by the offices, but sometimes it doesn't. There's no particular reason why it necessarily would every single day. Okay. So we can see that this data set, if we think about it a little bit, it's probably biased, and we need to be a little careful about how we interpret results. And that's a really common theme when we're doing data science, is we have the data, but we need to be a little careful about what biases might be present in the data, either because of how the data is collected or because of how we're interpreting the data, or maybe just because of what's observable and what isn't, what could possibly be in the data set. Okay. But that gives us a little bit of an interpretation, how we can interpret the data points we're seeing for Jing Quan's car, and it all kind of makes sense. That all seems pretty reasonable. So I was thinking, okay, that's interesting. What else could I look for? Who else's car can I find in this? Okay. Well, I had another idea. I thought, okay, let's think about other city officials whose official cars I might be able to see. And I was able to find another one. And I'll show you in our next video what happens when I start looking at the location where other people's cars have been seen. So see you in the next video.